before we go on to look at National 5 Pythagoras' theorem, we'll go back and look at the broad general education and a quick reminder of what we've done. When we're using Pythagoras' theorem, we need to remember that Pythagoras' theorem only works with right-angled triangles. So if you're doing a Pythagoras question, the triangle itself must be right-angled. Obviously, a triangle has three sides. We will have one side here in a right-angled triangle. You always have one side that's longer than the other two. In this case, it's this side, or in this triangle, it's this side. This is the longest side of a right-angled triangle, and it's called the hypotenuse. You can always find the hypotenuse opposite the right angle, so the side directly opposite the right angle is the hypotenuse in both these cases. The other two sides, as far as Pythagoras goes, we'll just refer to these as the two shorter sides. So the longest side is the hypotenuse and the two shorter sides. If we want to find the unknown length of a side in a Pythagoras question, we need to decide first of all, are we looking for the hypotenuse or are we looking for one of the shorter sides? Now the x in this first example is on the hypotenuse, the side opposite the right angle and clearly the longest side. So in this case I'm looking for the hypotenuse. So I'd probably just write out the word hypotenuse to remind me of the setup. So if we're looking for the x here, we're going to have x squared equals 3 squared plus 4 squared. In other words, the hypotenuse squared is equal to one of the shorter sides squared added on to the square of the other shorter side. So what we then need to do, remember here, is we're trying to get x completely on its own. It's currently been squared, so I need to undo that squaring. So I'm going to take the square root of both sides here, so x equals, that's me taking the square root of x squared to give us x, and taking the square root of the other side, I'm just going to write it out under a big square root sign with brackets, 3 squared plus 4 squared. What I can do then is I can type this all into my calculator in one go. Now, when you're typing this in, it depends on your make and model of calculator, but ideally just put the brackets in every single time. Square root of, open bracket, 3 squared plus 4 squared, and close the brackets again. And this will give me 5 meters in this case. Looking here at the second example, what we again have to do first of all is identify which of the three sides of the triangle I'm looking for. Now, the right angle's here, so opposite that is the longest side, which is the hypotenuse. So if 13 is the hypotenuse, then the x and the 12 both must be the shorter sides. So we're looking for one of the two shorter sides, so I'm going to start off by writing shorter side. Setup is roughly the same. The only difference is with the shorter side question, x squared equals 13 squared take away 12 squared. Now, the basic difference between the starting point for a hypotenuse question and a shorter side question is hypotenuse will always have a plus in the middle and shorter side will have a take away in the middle. Other than that, it's pretty much the same. The only thing you need to be aware of is obviously with the shorter side, if you are subtracting here, we do need to have the larger of the two numbers first. So it wouldn't be okay to put 12 squared take away 13 squared. It has to be 13 squared take away 12 squared. After that, the process is pretty much the same. We're going to take the square root of both sides. So again, just keep it all together, 13 squared in brackets minus 12 squared. Close your brackets again, type it all into your calculator, and again, this comes out to 5 meters. Couple of things to finish off. Basically, you might be wondering, why do I bother writing shorter side and hypotenuse? There's no marks for writing these two things. However, I just put them in because it serves as a little memory aid. It's the very first thing you do in the question. It starts to get you to think, and that way you never make the mistake, hopefully, with mixing up your plus and your minus. So writing this out is good practice, and I would encourage you to do it. If you come across a question like this in a non-calculator paper, then obviously from this step here, we need to be really careful to use BODMAS, our order of operations. So we need to be doing the squaring of the two parts first, then the addition, and then the square root is the last thing we would do there.